Hello students, let us continue with chapter 5, Introduction to Euclid's Geometry. So, we will be taking a look at a new topic, Euclid's fifth postulate. We have discussed about the 5 postulates, but the fifth one, as I said in the beginning, we will keep it for later. So, now is the time. Let us revise it. If a straight line falling on 2 straight lines makes interior angles on the same side of it taken together less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than 2 right angles. So, let us draw this and understand. So, if I have 2 straight lines and a line falling on them, and if the sum of measure of angles is less than 2 right angles. So, I will say sum of this angle here and sum of this angle here is less than 180, is less than 2 right angles, which is less than 180 degrees, because 1 right angle is 90 degrees. So, 2 right angles would be 2 into 90 degrees, which is 180 degrees, which means that if I extend these lines indefinitely, then they will meet at a point. This is what Euclid's fifth postulate implies. So, now using implying this postulate, many other postulates have come into existence, one of which is this. First of all, the implementation of the fifth postulate, what does it say? If the sum of interior angles on the same side is exactly 180 degrees, that is sum of 2 right angles, then if these lines, if extended indefinitely on the same side, they will not meet or not intersect. Then the 2 lines, if on the same side, if extended indefinitely, will not meet or intersect or not intersect, right? So, as I said, that there have been many equivalents of Euclid's fifth postulate. One such is the Playfair's axiom. Let us read out what it says. For every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. So, let us again draw this and try to understand. So, I have my line L and there is a point P that is not lying on L. Then there exists a unique line L passing through P and parallel to L. So, I am going to say let this unique line be M. So, M is parallel to L and it is passing through P. So, this is about Playfair's axiom. And the third equivalent of the fifth postulate is 2 distinct intersecting lines cannot be parallel to the same line. So, if I just modify this figure a little bit, let us see 2 intersecting lines. This is one line, I will call it say S, and this line I call it T. So, if you see these 2 lines S and T are intersecting and they are not parallel to L. So, any line that is going to be parallel to S will be something in this direction, right? And what about T? It is going to be something like this. This is what it means. 2 distinct intersecting lines cannot be parallel to the same line. So, they will never have any line. S and T are never going to have the same line that is parallel to both of them. Why? Because S and T are intersecting. So, if you want, I can just redraw it once again. This is L, this is P, point P, and I have M, and I have 2 lines intersecting, correct, S and T. So none of these lines M and L are parallel to both S and T simultaneously, and also no line will be parallel to S and T simultaneously. So these are the equivalent versions of Euclid's fifth postulate. So let us continue with the remaining topics of the fifth chapter in the next classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.